In our flask here we have 50 milliliters of water, 2 drops of phenylethylamine, and 0.6 grams of KHP. Here in our bird, we have NaOH, and our initial volume of the NaOH is 0.7. So now we'll drop the NaOH into our solution here until we see a visible pink color and change.
Do it on that side so you can see it, like stir it on the side.
See some pink color.
No, like I can't see. Use your left hand.
I'm right-handed.
Okay, I'll go right.
Getting closer. Our final volume of the NaOH is 26.3. Subtract the initial volume from the final volume, and that's the amount that you needed for the titration.
Here in our flask we have 50 milliliters of water, 0.06 grams of KHP dissolved in it, and 2 drops of phenylphthalein. In our burette, we have an initial volume of 6.7 milliliters. And now we'll start the titration process. And there's a final volume in the burette of 33.3 milliliters. Why are titrations performed? Titrations are performed to allow you to determine the precise endpoint of a reaction and therefore the precise quantity of reactant in the titration flask. What do you need to know before beginning a titration? You need to know the initial volume reading of the titrant solution in the burette. What data should be collected to determine the unknown variable? You need to subtract the initial volume to determine the amount of titrant delivered. You use this in the stoichiometry of the titration reaction to calculate the number of moles of reactant in your analyte solution. How to read a volume. First, notice that the burette has a 0 at the top with values increasing going down the scale. Then determine the scale increment. Use the graduations to find all certain digits. And finally, estimate the uncertain digit and obtain a reading. The burette was rinsed with water and solution 3 times before each use.
I'm Joe Bertram.
And I'm Kathy Reagan.